All right, so we have this Aleks problem, and the way we're going to do it is using this formula, which is that delta G is going to equal negative RT ln K. So that's this formula, and this problem is a lot simpler than it looks, but it's a couple of steps. So we're going to start out with this first question. We have a reaction vessel, and we fill it with 2.64 ATMs of dinitrogen tetroxide. So if we write out this equilibrium expression, we're saying that we start out by filling a reaction vessel with 2.64 ATMs of this N2O4, right? And we have 0 of this initially. So we know that we need to produce that NO2 since we had 0 of initially. So we're going to be shifting to the left. And it's asking us what's going to happen to the pressure of N2O4 if we are under these conditions, meaning we're shifting to the left, right? So when we shift away from something, its pressure is going to decrease. If we shift towards it, the pressure of it would increase. But if we're shifting away, it's going to decrease. So the answer for this first one is going to be that the pressure falls. And then it's asking us, can we reverse that tendency by adding NO2? So if our answer was that the pressure will fall, can that be changed to make it rise if we were to add NO2? If we were to increase the amount of NO2, right, this molecule, the system wants to decrease the amount of it, right? So it's going to shift to the right. And like I said before, if we shift towards something, we're increasing that pressure. So the answer here is yes. And now because we answered yes, we need to solve what amount of that NO2 do we need to add to reverse it. So based off of a little ice table in our coefficients from the balance equation, we know that this would be a plus 2x and this would be a minus x, right? And then our temperature we were given here is this 376 degrees Celsius. We're going to convert that to Kelvin by adding 273.15 because Aleks likes that decimal form. So if we add that, we get 649.15 Kelvin. And then our R is going to be that negative 8.3145. Our temperature is 649.15, and that's kelvins. And then ln K is what we're going to be solving for. And this is equal to the delta G value that they gave us, except we want this to be into joules because our R constant is in joules. So we're going to multiply that given by 1,000. So we get negative 5.4 times 1,000 gives us negative 5,400 joules. And now we're going to solve for K. So first just divide by this stuff, and then whatever answer you get, you're going to take e to the power of that. So we're going to do negative 5,400 divided by negative 8.3145 divided by 649.15. And then that answer, I'm taking the e to the power of it. So we get 2.72 is equal to K. And now our K, if we remember how to write the equilibrium constants, would be our products over the reactants along with their coefficients as the power. So we have the pressure of N2O4 over the pressure of NO2, which would be squared. And we were just told that 2.72 is our K, meaning it's equal to that. And we were given one of these pressures. We were given the N2O4. So we're going to have a numerator of 2.64, right, over that value squared. And now, just basic algebra, we're going to solve for x.